Vamos a escuchar la exposición de la reconocida ecóloga neozelandesa de ecosistemas de agua dulce, con especialidad en investigación de diatomeas endémicas e invasoras, como el Didymo. Su posición actual es investigadora del Instituto Nacional de Investigaciones de Agua y de la Atmósfera en Nueva Zelanda. Desde el año 2004 ha liderado y desarrollado más de 25 proyectos relacionados con la microalga invasora Didymo y presentado y divulgado sus resultados en diferentes publicaciones, workshops y conferencias alrededor del mundo, lo que la ha convertido en una voz líder en investigación a nivel mundial de esta plaga. Posee más de 20 publicaciones y reportes exclusivos en la temática del Didymo. En el día de hoy, la doctora Cathy Kilroy va a presentar la exposición Una década de Didymo en Nueva Zelanda.
Well, I just want to thank Maximo for his great organisation in getting us over here. Really appreciate it.
Me gustaría agradecer a Máximo por la oportunidad de venir acá.
And yeah, so as you're probably aware, we've had Didymo in New Zealand now for over 10 years. And I just want to share with you some of the experiences that we've had with it.
Si no sabían, si no sabían, nosotros en Nueva Zelanda tenemos Didymo hace más de 10 años.
Right, now then. Okay, this is the Lower Wire River in Southland, and this was the photograph taken when we first found Didymo there in 2004. It's a regulated river. So it's got a very steady flow.
Este fue el primer río que fue encontrado Didymo el 2004 y esta es la imagen que muestra células del Didymo y es un río que tiene un flujo bastante permanente.
Right, and this is probably one of the first good photographs of Didymo that was taken at that time.
Esa es la primera imagen que tenemos del Didymo presente en ese río, en esa roca.
In New Zealand. So when we found Didymo in the Lower Wire River, we traced it up. We were able to trace it upstream for about 100 kilometres. Actually, the blooms were all the way upstream, and they stopped or started at this point, which is the Kiwi Burn in the Mararoa River, a tributary of the Lower Wire. And it's a very popular input point for rafting and kayaking, so a popular tourist destination. And the blooms went up to this point and they were not upstream of this. So we assumed that this was the first point of incursion into New Zealand of Didymo.
Se asume que ese punto fue el comienzo de la expansión del Didymo, ya que es bastante recurrido para la gente que practica kayaking y diferentes actividades recreativas acuáticas.
Right, so as Max said this morning, the incursion of Didymo into New Zealand really raised the profile of Didymo worldwide as a potential invasive species because it was almost immediately recognized as non-indigenous, non-native, and it was declared an invasive species.
Se declara como no nativo y de todas maneras también se declara invasivo al país.
The government gave it the designation of an unwanted organism, which is an official designation, which means that money can be spent on it. It's a nuisance organism that we don't want in the country.
El mismo gobierno declaró al Didymo como una especie no querida en la zona y es un término declarado profesionalmente.
Yeah. And so they followed an intensive program of government-funded research in New Zealand to deal with Didymo. And a whole lot of that is on the website, and some of you might be familiar with that website. And one of the problems we had to deal with in 2004 that we had very little information about Didymo. We think there were only about 12 published papers available.
Uno de los más grandes problemas que tuvieron que enfrentar es que no tenían mucha información respecto al Didymo y solamente habían publicado hasta la fecha 2004 12 papeles dando información al respecto.
Yeah, and since then there's probably been about at least 10 papers a year published. So the New Zealand incursion really ramped up the interest in Didymo worldwide.
Entonces desde la fecha se han publicado 10 publicaciones respecto al Didymo desde el 2008.
So just to put it in context, this grey area we thought at the time was the assumed native range of Didymo, and these the pink areas show historic records of Didymo, roughly. It's diagrammatic, so it doesn't cover everything.
La zona gris que se puede ver en la pantalla es lo que se piensa la zona nativa en que se cree que comenzó el Didymo, y los puntos rosados son los que se tiene como antecedentes que existe el Didymo.
And of course, as Max said, Vancouver Island was the first report of unprecedented blooms, followed by Iceland and then Central Europe, and then New Zealand, and then a whole lot of other places. So that sort of traces the history of the blooms.
Todos los puntos que están con estrella indican los florecimientos más recientes que se han encontrado con la fecha incluida.
Okay, so I'm just going to run through these topics for the rest of this talk. Starting with a bit about Didymo biology. I'm sure you know all about this, so I'm just going to show you some photographs for 2 seconds. And then the response in New Zealand, some recent research, and then I want to ask the question about whether Didymo is non-indigenous in New Zealand.
Durante el momento voy a hablar sobre estos puntos que pueden ver en la pantalla, células versus tallos, la respuesta de Nueva Zelanda 2004-2008, investigaciones recientes, y una pregunta si es que de verdad la especie no es nativa, y el futuro del Didymo.
And then a little bit on the future. Okay, so Didymo, so that's Didymo, as you know, a rather beautiful looking cell. These are healthy Didymo cells with the stalks showing nice and clearly, polysaccharide stalks which make up the blooms. This is a photograph of the initial attachment of how a bloom really starts at the very beginning. Just a little attachment to a rock or hard surface here, and the stalk is then exuded by the cell. And the main thing to note about Didymo colonies is that, as Max said, all the cells are at the surface. So we get this succession of dividing cells, and all the cells end up at the surface.
Lo más importante que deben saber del Didymo es que todas las células se exponen al exterior.
And this shows it. Sorry, I'm not doing this very well. So lots and lots of stalk material and a very thin layer of cells at the surface. Okay, and you can see it again in that photograph. Okay?
Y pueden ver las células ahí en esa fotografía.
Okay, so in 2004, one of the first things I had to say is that a lot of organisations were involved in the response. It was coordinated by Biosecurity New Zealand, now the Ministry for Primary Industries, and most of the major environmental organisations were involved, many private organisations, and most of the universities.
Desde que se encontró Didymo en el 2004, muchas instituciones se involucraron en la búsqueda de más información y de investigaciones, ya sea instituciones públicas como también privadas.
So these were the main questions that we wanted to address. What is Didymo? As I said, we didn't have much information at the time. I'll gloss over that one. But the main things we really wanted to know was what harm does it cause? Where will it spread to? And can we control it?
Estas son las preguntas que debemos responder. Por ejemplo, ¿qué es el Didymo? ¿Qué daño causa? ¿Dónde se expande? ¿Y cómo podemos controlarlo?
Right. So, the main thing, of course, as you all know, is that it increases biomass in rivers incredibly. So this is the Lower Wire. This graph is from the Lower Wire River in Southland. This is the river where we first found it, near the site where we first found it, and we've been monitoring that river since 1997. Never found Didymo until 2004, and every time we've monitored since 2004, the biomass has been really high, even after quite large floods. So I think that speaks for itself. Okay, so these massive increases in biomass, we couldn't imagine that they would not have an effect on the ecosystem. And so we did do a series of studies on the effects on invertebrate communities, fish, and we looked at river birds and other algae. I won't go into those in detail. There's also economic effects. The effects on irrigation and hydropower intakes, they certainly cost those industries quite a bit at the time. And then, of course, angling and recreation. So all things that you're familiar with here. And these are basically the outcomes. Yes, effects on other algae. Yes, effects on invertebrate communities, which Max covered. I think Carol Ann will talk about that a bit more. Fish is still a bit of an open question. River birds don't seem to be affected. Irrigation and hydropower industries, yes. Angling, yes. Recreational activities, yes. I'll just leave it at that for the moment. Okay.
Can I?
Yeah, go.
Okay. Can you go back to the previous one? Yeah. Lo que comenta Katy es que es normal pensar que una alga tan invasiva como el Didymo puede causar efectos en el ecosistema. Lo que tuvieron que investigar es que sí causa daño en nuestras algas, sí causa daño en comunidades de invertebrados. En peces no se sabe todavía por el momento. En aves de río no. En la irrigación sí. En
angling, fishing.
En la pesca también y actividades recreativas también.
Right. Okay, where will it spread to? Yeah. So, as part of the response, the Biosecurity New Zealand organised a series of delimiting surveys, which where we developed the sampling methods, and starting in 2005. We started doing major surveys about every quarter and developed these maps to show how Didymo had spread around the country over the next 5 years. So as you can see in 2004 it was in one river, and then in 2005 it jumped to several other rivers and continued to spread gradually to a whole lot of other rivers until almost the whole of the South Island was affected by 2009.
Se empezaron a hacer monitoreos a los ríos contaminados desde el 2005 y, como pueden ver, empezó a esparcirse desde 1 a 7 y así sucesivamente.
The main thing to notice, of course, is that the North Island, not a single positive find. So no Didymo in the North Island up to 2009, despite a lot of sampling.
No se encontraba Didymo en la isla del norte hasta el 2009.
And as of 2015, I've added a few more cases in the South Island there where we've discovered Didymo. But it's pretty much the same as it was in 2009.
Aquí podemos ver un mapa del 2015 en el que se puede apreciar que es exactamente igual que el 2009.
And of course there's still no Didymo in the North Island. There's continued monitoring up there about every year, but as of now, no, and they use the molecular method, sensitive molecular method to detect it, but no Didymo has been found there. So the North Island is free of Didymo as far as we know.
Cada año se monitorea la isla del norte, en la cual hasta la fecha no se ha podido encontrar restos ni presencia de Didymo.
Okay, and just to step back to one of the One of the things that we did do in the first response was to do some modelling to try to predict where Didymo would go using what we assumed was its ideal habitat. And this was what we came up with in 2007. Oops. This map here. And you can see that it sort of, it generally follows what's actually happened by 2015. The densest infestations are down here, and the North Island, the blue and the green, means very little Didymo is expected.
Se creó un modelo en que se podía registrar cómo el Didymo podría esparcirse en el país, y como pueden ver siguió el mismo patrón que se puede ver en el resultado del 2015, dejando la isla del norte libre del Didymo.
And I should say that those maps, most of the sampling was done in large rivers. We haven't sampled many small rivers, and some small rivers even now are completely, there's no sign of any Didymo. We haven't detected it. But some small rivers do have plenty of Didymo. So we've got a bit of both.
Se ha detectado que mayormente se encuentra Didymo en los ríos más grandes, sin embargo, igual se ha registrado en ríos pequeños, como pueden ver en la imagen, cubiertos completamente con Didymo.
So the next question was, can it be controlled? I think... Oh, sorry. The main outcome of the control effort in New Zealand was this Check, Clean, Dry campaign. Okay, so to do this, we developed these methods for cleaning Didymo. We did laboratory tests to show that these things actually did kill Didymo cells, and this poster was posted at rivers throughout the country, and it's the same as the message that we've been seeing from you guys earlier.
Se crearon estos póster para prevenir la expansión del Didymo con los 3 puntos que ya todos somos muy familiares, que es el remover, limpiar y secar, y se hizo investigaciones en el cual probaban de que las células del Didymo desaparecían.
And you'll notice that this Check, Clean, Dry message applies to Didymo and other aquatic pests. And that was the message right from the beginning, and is definitely the message today, and I'll mention that a bit later.
No solamente este proceso se utiliza para erradicar el Didymo, pero también para otro tipo de pestes que trabajan de la misma forma.
So the government response to Didymo wound up in 2008 and 2009, and the responsibility was handed over to local authorities to deal with, rather than a central government issue. It became a local authority issue. Okay, and so since then, a lot of emphasis has been on, as well as sort of locally dealing with Didymo, more emphasis was put on some research to understand what Didymo is all about.
El gobierno se hizo caso de las investigaciones, pero también los gobiernos locales tomaron en cuenta para poder empezar a hacer investigaciones para tener más información respecto a esta peste.
Right, and so I guess these were the 2 main research questions, and Max has covered the first one, but I'm just going to expand on that a little bit. How is it possible for Didymo to bloom in oligotrophic waters? And the second one, is why isn't Didymo in the North Island? Okay.
La primera pregunta es cómo puede ser posible que florezca en aguas oligotróficas, con el experimento que se realizó con Mr. Max.
Right. So I'll just show this again. These were the channels that we set up beside the Waitaki River, and that's Max tying his shoelace. And we did a series of experiments here, apart from the ones that Max talked about this morning. Oh, the battery's running out. Can you plug it in? I'll carry on. Yeah. So the channels were set up beside the Waitaki River, which is a large regulated river which has had huge blooms of Didymo since about 2006. And so we had a very good source of Didymo, and it's also an extremely oligotrophic river, very low phosphorus and very low nitrogen as well. And so this was the water source that we were using for these experiments from the river. Okay, and that's the location.
Este fue el río que utilizaron para los experimentos con bajo fósforo y bajos nutrientes.
And so, as Max said, one of the first things that we found out was that that Didymo cells respond to added phosphorus by increasing their cell division rate, even though we're taking the water from a river, this oligotrophic water from a river which is absolutely full of Didymo. Okay, so this was the first important finding, which Max explained very nicely this morning, much nicer than me. So, but one of the other things that we did was we measured stalk length in Didymo, just to look at the mechanism of what was happening when cell division rates increased. And so what we found was that we measured stalk length, and we've plotted this against the frequency of dividing cells. And what we find is that when you have low dissolved reactive phosphorus and high light, you get very long stalks. And when you get low light or high dissolved reactive phosphorus, you get short stalks. And that is simply what Max was talking about this morning.
Lo que se pudo observar en el experimento es que la rapidez de la división de las células se vio afectada por el fósforo en los ríos, en el río que fue sacado para la muestra.
Yeah, so what we think is happening is when Didymo has lots of phosphorus, it can happily divide fast, and it doesn't produce any stalks. But when the phosphorus levels become depleted, the cells keep photosynthesizing and making carbohydrate, and that gets pushed out into the stalks as a sort of byproduct. And so this is what causes the huge long stalks that you get in low phosphorus.
Cuando se le quita el fósforo al dídimo, este se reproduce aún más rápido y sus tallos pueden verse más largos.
And so we matched this up with field service. I think Max showed this graph this morning. The frequency of dividing cells, so the cell division rate in rivers, was also related to dissolved reactive phosphorus. And actually, this is exactly the same graphs that you showed. Yeah, but this is a different way of showing it. What we find is that this is a standing crop index, which I don't know if you guys use it. A standing crop index is the aerial cover of Didymo multiplied by its thickness, okay? And so that can give you, so if you have a standing crop index of 1600, then you would have, say, 100% cover, and it's 16 millimeters thick. So that's how we calculate it. And so if you plot that against phosphorus, you see you don't, all the high standing crop index is at phosphorus levels of less than 2 parts per billion. 2 parts per billion, yeah, you get that? So high standing crop, low phosphorus. The 2 parts per billion phosphorus is a really, really low level of phosphorus. It's below the level of some lab tests, below the detection level of some laboratory tests. Can you? That's okay. It's all right. Okay. So the conclusion from these, as Max said, was that Didymo blooms do seem to be caused by low dissolved inorganic phosphorus, almost below detection, because that's when they produce all their stalk material.
La causa principal del florecimiento del dídimo es causado por una baja en fósforo inorgánico.
Right, now we also looked at, actually if you think about it, if low phosphorus causes Didymo blooms, if you put a little bit of phosphorus in the river, maybe you can get rid of the blooms. Okay? And so we see this. We see blooms disappearing downstream of point source inputs of phosphorus into a river, such as sewage treatment plants.
Se ha observado que si uno introduce fósforo a los ríos, se puede ver que las células del dídimo desaparecen.
So we've run an experiment in a river that's full of Didymo, has very low phosphorus and very low nitrogen, in which we added phosphorus in these experimental channels in the river, phosphorus and nitrogen actually. In fact, we added nitrogen, phosphorus, nitrogen plus phosphorus, and then had a control. And we did two things. We looked at growth of Didymo under the different conditions in each of these channels, and we looked at the growth of Didymo upstream of the coverage of Didymo upstream of the channels compared to downstream of the channels where they were getting a little bit of phosphorus.
So, se hicieron diferentes investigaciones añadiendo nitrógeno, luego añadiendo fósforo, luego añadiendo nitrógeno con fósforo, y se hizo un control para visualizar los diferentes cambios y si se producía un florecimiento del dídimo.
So what we found was, first of all, looking at the cover and Didymo cover and standing crop upstream and downstream of the channels. And this is the standing crop index, which I forgot to label. We find that the downstream, downstream of the channels and upstream of the channels weren't any different during our first experiment, because in our first experiment, the amounts of Didymo of phosphorus that we added were extremely low. They were less than 2 parts per billion. Okay? But when we carried on into experiment 2 and added higher concentrations of phosphorus, we found that the cover of Didymo downstream declined a lot compared to cover upstream. Okay? So adding a small amount of phosphorus in that system caused a decline in Didymo cover downstream compared to upstream. Is that too difficult? And this was over a period of several months. So we started the experiment, this is before the experiment, we started the experiment in April and we went through to October. So it took a long time. So that was one thing. We showed that you could lower the amount of Didymo in a river by adding a small amount of phosphorus.
El siguiente gráfico muestra cómo era antes el río.
Yeah, okay.
Y después cómo a través de los meses se pudo ver un cambio en la parte baja del río y en la parte alta. Añadiendo más fósforo, se podía ver que
It's okay.
que la cobertura del Didymo era aún mayor.
Right, now the other interesting thing that we found in this experiment was that there was a nitrogen effect. Okay, so what you see here is we were growing, this is Didymo growing on tiles in the channels that were in the river, the wooden channels. And so we had 4 treatments: control, added P, added N, and added N plus P. Okay, and Didymo mats only grew when we added nitrogen. They didn't grow, they grew a little bit with just phosphorus, but you only got big Didymo mats when we added nitrogen.
En el siguiente experimento se añadió nitrógeno, en el cual pueden observar que el florecimiento creció aún más añadiendo nitrógeno que añadiendo fósforo y nitrógeno junto a él.
So here, the control here, we weren't getting any growth. We weren't able to grow any Didymo or anything else, actually, in the ambient river water, which was very low in nitrogen and phosphorus. Okay, so another conclusion from this could be that Didymo blooms don't form unless dissolved inorganic nitrogen concentration is more than about 10 parts per billion. And the 10 parts per billion came from the levels in the experiment that we observed.
Otra conclusión podemos tomar es que el Didymo no florece de no ser que se disuelva con nitrógeno inorgánico en más de 10 partes por millón.
Anyway, so for me, this was quite revealing, because I'd noticed over the years that Didymo wasn't growing in some streams which we'd monitored regularly, which had extremely low nitrogen, but they also had extremely low phosphorus. So I couldn't understand why we weren't getting the blooms, and all of a sudden, it was explained. So there needs to be a source of nitrogen before Didymo will bloom as well. And in New Zealand, that's quite important, because a lot of our high altitude streams have got extremely low nitrogen and phosphorus.
Lo que se pudo observar en esta investigación es que se necesita nitrógeno para que el Didymo pudiera florecer.
Okay, so just to sort of sum that up, low dissolved phosphorus, less than 2 parts per billion, some dissolved nitrogen, more than 10 parts per billion. That sets you up for Didymo blooms, as long as everything else is right. And I also want to point out that other water chemistry conditions, including high nitrogen, seem to inhibit growth of Didymo. Okay. Does that make sense? That's okay.
What is DIN?
I think so Didymo blooms need nitrogen, so I think we've got that, haven't we? Yeah, but high nitrogen is also inhibits Didymo blooms. Okay, so actually this slide looks a bit out of place now, but I just put it in. This is what Max has covered this morning. If we go global again, and we look back at what Max was talking about this morning, about the global expansion of blooms possibly being linked to declines in dissolved reactive phosphorus, and this is a quote from the paper that was in, it may be that there is a bit of a nitrogen story there as well. So, but it's all environmental. That's what I'm trying to say. Okay. Okay. So, right. So that's the nitrogen thing. I'll just spend a few minutes just talking about why Didymo isn't in the North Island. This is a really striking pattern that people in New Zealand can hardly believe, actually. It's all over the South Island, not a single case in the North Island. Why?
La pregunta que se hace muchos gente en Nueva Zelanda es por qué no se encuentra Didymo en la isla del norte, solamente en el sur.
So we've looked at a few things over the years to try to explain this, because this was something that was obvious right from the beginning, actually, when we were doing our modelling, that North Island was coming out much less susceptible. And one possibility was temperature. And so we looked at the global distribution of Didymo, and we found that Didymo seemed to be restricted to places where the mean temperature in the coldest month was less than about 5 degrees centigrade. Okay.
Una de las razones que podían interesarse era en la temperatura del medio ambiente. Por lo que se puede decir es que el Didymo prefiere las temperaturas bajas.
So it seems to need cold winters. And when you put that winter temperature contour on New Zealand here, you've got quite a big chunk of the North Island that seems to be suitable, but a lot of it isn't. And almost all of the South Island is suitable.
Como pueden ver en la imagen, el sur es bastante ideal para que el Didymo pueda crecer, sin embargo, el norte no es ideal para el crecimiento y el florecimiento del Didymo.
Now, we have no idea any physiological reason behind this yet. We don't know why Didymo would like a cold winter, but this is one correlative possibility for its absence from the North Island.
No existe ninguna investigación que pueda probar por qué el Didymo prefiere el clima más frío, pero es la única razón que pueden encontrar hasta el momento.
But the work I did with Max gives us a much more definite reason, which is that most North Island rivers have much higher phosphorus concentrations than South Island rivers. A lot of that is natural phosphorus because of the volcanic geology.
Como explicó, es que la mayoría de los ríos en Nueva Zelanda tienen un alto nivel de fósforo.
So these are sites from throughout the North and the South Island, and I'll just put on there, the red dots then are sites with visible Didymo. The size of the circle indicates the concentration of phosphorus. Okay, so you can see that Didymo is at sites only where phosphorus is really low, and almost all the sites in the North Island have got higher concentrations than that.
Los puntos rojos muestran los lugares en que el Didymo ha sido visible y los puntos azules donde indican un nivel alto de fósforo en los ríos.
Right, so the phosphorus is one thing. Another thing might be other aspects of water chemistry. So we do have water chemistry data for many sites around the country. And this is an ordination of all the sites we have data for, using major ions, sodium, potassium, magnesium, calcium, and then pH, conductivity, and dissolved humic material, watercolour. Okay, and you can see that the North Island and the South Island form two precise groups with some overlap. And when I put on the South Island Didymo sites, they form another little group with a little bit of overlap with the South Island, but not much with the North Island. So we're looking here at another difference in water chemistry between the two islands. And one of the main differences is sodium. Okay, so sodium concentrations in the North Island are always and in the South Island, where there's no Didymo, are always higher than at sites with Didymo. Okay, and the second one is percentage of calcium, and we already know that Didymo, from the work in Norway, that Didymo requires some calcium, and so that percentage calcium is quite important as well. So that's another water chemistry reason which may be restricting Didymo in the North Island, and maybe even preventing it establishing there at all. If it was just phosphorus, we might expect to find some Didymo, but no blooms. But we don't find anything, not a single cell. Okay, so that's the North Island. I don't know how I'm doing for time. I just want to talk a little bit about whether Didymo is non-indigenous, non-native in New Zealand.
Ahora va a hablar sobre por qué el Didymo es visto como una especie no nativa en Nueva Zelanda.
So, Max has given a really strong argument for Didymo in the Northern Hemisphere, in America, for Didymo blooms probably being stimulated by declines in phosphorus, or some other water, or combination of water chemistry changes in those rivers. And so the question is, was Didymo always in New Zealand and just popped up in 2004 when some environmental change occurred?
La pregunta es, ¿siempre ha estado el Didymo en Nueva Zelanda o el 2004 apareció así de la nada?
So, first of all, there is one record of Didymo in New Zealand. It's in the North Island, which is interesting. And it was recorded in 1928 in a master's thesis.
Hay una información de presencia de Didymo en 1928.
Yes, so this is the only record, and I'll show you the record. It's this. So we've got, Gomphonemer geminatum there, and it's supposedly occurred in a little dried up creek somewhere near Wellington. And so here's another record from the same thesis where she's put Gomphonemer geminatum and then she's changed her mind and put constrictum. So we wonder whether she mixed those up, whether it was a misidentification. Unfortunately, there's no drawings for us to look at, there's no samples, so it's just conjecture. We don't know, but it seems highly likely that it was a misidentification.
Lamentablemente no hay ningún tipo de muestra que reafirme el hecho de que hayan encontrado Didymo en esa fecha, solamente esta información.
So, the other question then is, was there an environmental reason for the arrival of, or the sudden appearance of Didymo blooms in 2004? And following on from this morning, did dissolved reactive phosphorus decline in New Zealand rivers just before then and suddenly stimulate the arrival of Didymo, or the appearance of Didymo? Now, one of the problems with this phosphorus theory is that it's very hard to, we haven't really got a lot of data to back it up. And the problem is that the phosphorus levels that are required to stimulate Didymo blooms are well below the detection limit of many chemical tests. But in New Zealand, we do have some good data which has taken DRP down to a detection limit of 1 part per billion since 1989. Okay? And we have that data for 77 sites in the country since 1989. So that's a pretty good record. Okay, and these are all the sites, and the data is all online actually. So, I'll just give you an example then. So this is the phosphorus record from the Clutha River, for example, which first got Didymo blooms in 2006. And so that's what it looks like. So actually, that's two sites on the Clutha River. The orange line and the red line are two sites. So it certainly doesn't look as if there was a decline in 2004. Then, in fact, it's going up. Not at those particular sites. Now, I also find this next slide. I hope you can see it. It's a bit busy. So these are South Island rivers then. So I've got 12 South Island rivers here, all with Didymo. And what I've done is I've got the mean annual phosphorus for each year since 1989 to about 2012, I think. And the orange spots are covered by Didymo, because as it happens, we also monitor periphyton. We also monitor algae at all those sites since 1989. So we've got a lot of information here. And so it's a bit variable, but what you can see is, or what I see anyway, is that there's no real sign that phosphorus has declined since 1989, in between 1989 and 2004, in a way that would suddenly stimulate those blooms.
Las barras azules indican la cantidad de fósforo medido anualmente, y los puntos naranjos son la cantidad de presencia de Didymo. Y no se ve que la media haya declinado a través del tiempo, desde el 1989 hasta el 2004, que son todos esos datos que están ahí.
Okay, so I'll leave it there. So, as far as I'm concerned, I don't find any evidence there that we've had a phosphorus decline, certainly not with this data anyway. So finally then, I just want to talk a little bit about the future with Didymo. The future in New Zealand is with Didymo. I don't think we can get rid of it, not now. It's all over the South Island. But we can manage it. There's a few rivers which are very badly affected by Didymo, and it's really caused a problem.
Podemos erradicarlo, tal vez, y dice que hay unos ríos que están terriblemente contaminados por el Didymo.
So one of these is the Apua River in Canterbury here. This is also a dammed river. It's been dammed for irrigation. And ever since Didymo appeared in the river since 2008, it's been a massive problem for the irrigators during the season. Huge amounts of Didymo clog up the screens, which are supposed to stop trees and stuff getting into the irrigation races. And then this is a massive mound of Didymo that came out of the self-cleaning, the self-cleaning intake.
Desde el 2008 el Didymo ha causado estragos en ese río, ya que ha bloqueado el sistema para evitar que ramas y árboles vayan a través del río.
Yeah. So there's not one option we can do, because it's a dammed river. We can put flushing flows down to clear the river out every now and again, and that's what they do. And what we've done over the last couple of years, we've worked out ways of optimizing those flows, so we can put the flows down at exactly the right time with the tides and the amount of Didymo, and we can have maximum effect for that flush. Okay, and this is some of my colleagues doing some gauging with a very fancy gauging instrument. So, okay. So we've monitored Didymo cover before and after the flush, and we found, of course, that regrowth is always really rapid. But even with this, during this regrowth period, the problem for irrigators is no longer as bad as it was here with the established blooms. So we're living with it there. Okay. Another thing is that we can now at least in certain areas, we can try and predict whether Didymo is going to turn up in streams or not. And this was some work that we did for the New Zealand Defence Force, who have a big military training area in the central of the South Island. Okay, and they were worried about spreading Didymo, actually, but they were also interested in whether it was going to occur in some of their streams or not. So we devised this little sort of decision support thing. So requirements for presence, calcium, and pH as well. I think, as we know, Didymo doesn't do anything in low pH. So calcium and pH. And then requirements for bloom formation. So what we need, we need low dissolved reactive phosphorus, but mean dissolved inorganic nitrogen. I've got 5 there, 5 to 10, before you'll get a bloom. And then if all of these are met, then some local conditions might limit the number of blooms. And that's flood frequency, stable bed substrate, and shade. Okay, and so you can come up with it. Anyway, so this is just an example of the sort of things that we can do just to try and understand what's going to happen. And what I'm also going to say is that in large regulated rivers like the Waitaki and probably the Apua, I don't know at this stage whether there's anything we can do about the blooms. Our experience in the lower Waiau over the last 10, 11 years is that the blooms have not really abated. They've not declined over time. They're just carrying on. Okay. And I showed this photo before. This is a little river in Canterbury. So we've also got small rivers that are very susceptible to blooms. But we've also got, actually you can't see that very well, we've also got small rivers that don't have blooms, but they have plenty of other algae. And this is a river in a dry part of Canterbury, which is in a long dry period. I would expect to see Didymo in this stream, but you don't see it. And it's only just downstream, so there's no reason why it shouldn't be there. So,
hay ríos pequeños que están completamente tapados con Didymo, pero a la vez, como pueden ver en la imagen, ese río no tiene Didymo, pero sí otro tipo de algas en él.
Right, and this is a high country stream coming off the mountains. It also doesn't have Didymo, but I'm pretty sure this stream, well, I know actually, this stream has very low nitrogen and very low phosphorus.
Como pueden ver, en este río tampoco existe Didymo y tiene las condiciones necesarias para que deba crecer.
Yeah. And once again, we know Didymo is in this catchment. It's definitely downstream, so it's not like it hasn't got there. And of course, there's rivers on Stewart Island, which is our third island off the bottom of New Zealand, which I don't think will ever get Didymo because they're acidic, yeah, and wetland country. Okay, so just to wrap up, so this check, clean, dry message is still being pushed by Ministry of Primary Industries, who manage these issues. But really the emphasis now is on all of this, Didymo and other aquatic pests. So these check, clean, dry messages and the cleaning methods as well are actually under review at the moment, so that we can include more organisms in this message. Because one of the good things that Didymo did was it did raise people's awareness of how you can spread things from river to river. And I'm sure that happened in New Zealand, actually. I'm sure that Didymo did arrive in New Zealand. It spread from river to river by human means, largely, but it's got where it's got to now. And I think any further spread of Didymo in New Zealand is probably going to be attributable to environmental changes. Maybe I'm sticking my neck out there. Maybe there's little parts of New Zealand that are still free of it. Like But mostly, I think any changes from now on would be environmental.
El mensaje de 3 puntos, como ya conocemos, sigue siendo puesto por el gobierno, pero ahora se incluye, además del Didymo, otro tipo de pestes que puedan cambiar la ecología.
So, this is just to sum up. What have we learned over these 11 years? Well, Didymo effects, it seemed like it was a terrible, well, it was actually, and it still is. It's still something we don't want. But the ecological effects probably not as severe as were initially feared, because Didymo didn't get everywhere that we thought it would. There are still Didymo-free rivers.
¿Qué hemos aprendido en estos 11 años? Que el efecto del Didymo no es tan severo como se pensó, pero de todas maneras todavía causa preocupación.
And then the cause of Didymo, low dissolved phosphorus, that was a really important finding. The continued non-detection in the North Island, I've covered some likely environmental explanations. We still don't quite understand it, but I think the phosphorus thing explains a lot of it. But we don't quite understand why it's not present at all, not in any quantity.
Todavía no se sabe por qué en la isla del norte no se ha detectado signos del Didymo, pero eso obviamente va a surgir durante el tiempo de investigaciones.
Yeah, and so the low DRP as an approximate driver of blooms is completely plausible hypothesis for the global expansion of blooms. But for me anyway, I find no evidence suggests that Didymo was not a new arrival in New Zealand in 2004. But I'm still open to... We can never prove that something wasn't there or isn't there. You can only prove that it was there, and maybe somebody will do that one day. But at this stage, there's no evidence to suggest that it was. Thanks. That's all I have.
¿Alguna consulta? Adelante.
Le quería preguntar si ella cree que las medidas de bioseguridad de Nueva Zelanda son las responsables de que la isla norte no tenga Didymo, o si es una característica ambiental.
Do you think that the measures that New Zealand has taken is the one reason that Northern Ireland doesn't have Didymo?
I think after 10 years, 11 years, if Didymo hasn't, it would be astonishing if somebody hadn't brought Didymo into the North Island. I think it's unlikely that simply the check, clean, dry measures would have stopped Didymo. We saw it jump 400 kilometres in the South Island while there was supposed to be while there were supposed to be controls in place, and basically I think it's unlikely that the measures would have stopped it.
Ella dice que no cree que sea la razón por la que no se ha encontrado Didymo en la isla del norte de Nueva Zelanda.
Yes, is it about the measures or environmental? What do you think?
Oh, from not in the North Island. Environmental. Environment. There's a lot of evidence to suggest that it's environmental. It fits the picture. Phosphorus is very high. It's not suitable for Didymo blooms. The water chemistry is volcanic water chemistry, and it's different to the water chemistry that Didymo thrives in. So,
Más ambiental, porque los niveles de fósforo en la isla del norte son un poquito bastante mayores que los ríos de la isla del sur, y que además con la temperatura, pero además con las medidas.
Yeah.
¿Cree que es muy poco probable que sea solo eso?
Having said that, there are a couple of rivers in the North Island which, if you look at the water chemistry, it is starting to be almost suitable for Didymo. Yeah, so you can, yeah.
Algunos ríos de la isla del norte que están siendo
Que tengan las condiciones.
tienen las condiciones para ser aptos para
Yeah.
tener Didymo.
And so we are watching those very carefully.
Y los están
Yeah, yeah. There's monitoring in those rivers just to see, because they seem, if Didymo is going to get anywhere in the North Island, then there are a couple of places that look suitable.
Si el Didymo
Yeah.
empieza a esparcirse en la isla del norte, va a ser por esos ríos que están peligrosamente cerca de las condiciones aptas para tener.
Otra pregunta quería hacerle. Hace poco nos visitó Jeff y Jeff Donaldson. Nos visitó y nos decía que, en Argentina, y nos decía que de la isla sur tendrían aproximadamente 400 ríos y 200 con Didymo, y que el resto de los ríos él creía que por las medidas de bioseguridad estaban protegidos. ¿Qué opinaba Katy de eso? Jeff Donaldson.
Recently, they were visited by
Jeff Donaldson, I know him. Right, yeah.
and he said that about 400 or no 2,000 of the 200 of the 400 of rivers in the South Island with Didymo aren't contaminated because of the measures taken by the
Oh,
government.
did he say that? Oh, I don't know.
Is
I
it-
mean, he can say.
What's your opinion about that? That's what he asked.
Well, I would say that knowing, when I go and sample catchments, Didymo is present. If you sample a catchment now, it's present in all catchments actually in the South Island, but it's not blooming in many. It doesn't bloom in many of them. I think after 11 years now, it's got to pretty well all the places it can get to. It spread really fast, and it hasn't changed between 2009 and 2015.
Dice que realmente,
Yeah.
como no se ha visto tanto cambio entre 2009 y 2015, el Didymo ya llegó a todas las partes en que puede estar y básicamente no se ha esparcido por eso. Esa es su opinión personal.
That's my opinion, though.
Esa es su
I mean,
opinión.
it's difficult to know.
¿Alguna consulta más? Ok, los invitamos a un coffee break y de ahí retomamos con las últimas tres exposiciones.